Hello, I'm Kaz. Yesterday I put up a video about some of the economics of stimulus. Got a really positive response. I was kind of surprised at how many of you guys watched it, so thank you if you watched it. Today I do want to come back around to economics, and I've got a couple more ideas for videos that I think you guys will enjoy, give you a little insight. Specifically, I want to do a video on why we're all so terrible at staying inside to help people out, because there actually is, an economic way to think about that. Today we're taking a detour though, and I want to talk about math because there's a lot of people, I think, and I've heard this even before yesterday, but a couple of people yesterday brought it up, that people are stuck at home with their kids and people don't really know how to teach kids math. And I'm not saying that I necessarily even know how to teach kids math, but I do know a thing or two about math, so I want to explain it. Mainly this is geared towards me explaining to you, the parents, and then you can hopefully help your kids out a little bit more. If you want to show your kids this video, by all means do, but mainly this is just going to be geared towards talking to the adults. I'm going to do probably 2, maybe even 3 videos on math, just basic kids math essentially. They'll progressively get a little more advanced, so the last one will be geared more towards like high schoolers and things like that. But we're starting off all the way at the beginning, so this one is very basic. We're actually starting off with counting, so if you know how to count, then this video is going to be right up your alley. And just a couple exercises you could do with kids that I think I'm not a teacher, but I think will probably pay dividends later, and actually sort of to help you out with learning like multiplication and things like that later. And it's sort of the biggest thing I want you to take away from this video is the way to think about math, because a lot of people have bad experiences with math professors in the past, just don't like math, and I think that math is a very hard thing to teach because some people just get it faster than other people, and out of necessity you sometimes end up sort of leaving some people behind as you're teaching it. Just it's very difficult to teach a full class, so props to all our math professors out there that are doing it every day. It is hard work, and you're fighting the good fight, so keep up at it. For now, I just wanted to talk about a couple of things, hopefully to help you out. We're going to go start off with counting. We'll make it up through basically multiplication and how we think about multiplication. So real basic stuff. You guys are all going to be able to understand this. We're going to head over to the whiteboard now, and we'll check out a couple of things and hopefully teach you a couple new things today. So let's go check that out. All right, here we go. We're at the board. We're just going to check out a few things. First off, like I said, we're going to start with counting, and specifically counting by 2s and 3s, because I can't really teach your children to count. That's going to be a little bit on you. But if you then teach them when they're ready to count by 2s and 3s, that's going to help them when they move to multiplication. And obviously they'll sort of go through addition and everything. I wouldn't know the first thing about really how to teach addition, so we're just going to start with sort of counting and how that applies to multiplication. And then how I think about multiplying things and how I multiply bigger numbers and things like that in my head. I think a lot of people do it this way, but I can't tell you that for sure. It's just how I think about it. Hopefully it'll be a new perspective for you, and will help you out as well. So what we're going to do is we're going to look at some dots here. 4, 5, 6, 7, 8, 9, 10. So I've got 10 dots there, right? And hopefully you guys can see those all right. And let me make that one a little bit bigger maybe so it's obvious. So we got 10 dots. Normally when you're counting, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And that's how you count. If you were going to count by 2s, you'd skip over that first one. You do 2, 4, 6, 8, 10. What I want you to do is, rather than skipping over like that, is let's just do this. Obviously now we have 20 dots because I have a second row there. Let's just count each, how many dots there are. We'll count one column at a time and count the dots that way. So we've got 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. And so doing that is just going to give us a little bit different framework. And what this framework is, you can then do it with 3s. Let's do it with 3s. I think beyond that, it's going to get a little bit challenging for most kids to count. You can go to 4s if you are ready for an extra challenge, something like that. You aren't going to catch me counting by 6s anytime soon, because I would screw that up after about the 4th or 5th one probably. So if you count in 3s, you got 3, 6, 9, 12, 15. I'm going to stop there. 18 is the next one, but if I keep going, I'm going to screw up one of them. So that is counting by 3s, is you're just counting how many dots there are as you move a column over. And what this gets us to is, this is 3 by 10, right? Which is 3 times 10. So normally that's when you're talking about multiplication, that's what you're going to say. You're going to say 3 times 10 or 10 times 3. Multiplication is nice in that you can do it either direction and it's the same. And so you have, yep, 10 this way, and you have 3 this way. And it doesn't matter if you do three columns of 10 rows or 10 rows of 3 columns. You have the same number of dots here. So we could just rotate this thing if you wanted, and make it tall instead of wide, and that would be the same number of dots, right? So this is actually basically what you're doing when you multiply is you're counting in 2 dimensions, more or less. So you are just counting by however many numbers you're multiplying. So you're counting by 3s in this case, or you could count by 10s if you wanted to. You know, the other way to get this would be to look at it this way across and be 10, 20, 30. And that's, you know, probably going to be a much easier way to count for many of you. This is where the terms squared and cubed come from, is the fact that you've got this square right here. And there are 9 dots in that because we've got 3 by 3. And in a subsequent video, we'll talk about area of squares and rectangles and things like that. And that's, you know, we'll come right back to this. But this is 3 by 3. There's 9 dots in there because 3 squared is 9. If you had, you know, an extra like that, that's 4 by 4. That's a 4 by 4 square, 16 dots, because 4 times 4 is 16. And this is the important thing that we're going to talk about. Is if I can get this, there we go, is the fact that you can use multiplication that you know to get to multiplication that you don't know, and you can do it by just manipulating these dots a little bit. And so this is a way I hope that will be helpful for you. This is how I think about it: is if you think in shapes more than you think in just numbers, then that's going to make things a little bit easier on you. So yeah, that's squared. If we were doing cubed here, just to come back to that, if we were doing cubed, what we do is we'd have that square of 3s. We do 3 of those squares 3-dimensionally. So if you get into, then you're changing dimensions. So think of it as you've got this square, the square of 9 here. You're doing 3 of those squares progressively going like back into the board. So you've got one out here, and then one a little further back, and then one a little further back, and that's giving you a cube. If you thought about it, it'd be like a Rubik's cube. Then you've got you've got 3 times 3 times 3, which would be 27. You've got 27 dots in that cube. That's where squared and cubed come from. And we're not going to get into exponents right now, but that's how that works. So counting by 2s and 3s got us to this stuff, led us into geometric multiplication. I'm just calling it geometric multiplication. I don't think that's a technical term. That's how I think of it, because you're doing geometry, you're using shapes to do these multiplications. So now that we've got that, let's talk about how to get to something that you don't know. So let's we've got 3 by 10. If we want to do 4 by 10, we just add another row, right? And we go from 30 to 40 because we're adding 10 in there. Let's do one for demonstration that would be a little bit harder. Let's do like 4 times 7, or let's do 6 times 7, I guess. 1, 2, 3, 4, 5, 6, 7. All right, so we've got. Right now, we'll start with 3 by 7, I guess. So this is going to be 21. I know that one off the top of my head. But how we can go about that is we're counting in 3. So 3, 6, 9, 12, 15, 18, 21. And that's going to get us there. If you know your 7s really well too, then you can do it this direction and do 7, 14, 21. And even if you just know 14 off the top of your head and you're like, well, okay, then let's just add 7 to that. And you can even just sit there and figure it out if you want. You can just count up 7 times on your hand. Okay, we're at 14, then we go 15, 16, 17, 18, 19, 20, 21. And I've got 7 figures up, so I counted 7 more dots. We're at 21. So how we often think about this, I guess let's go to, what did I say, 6? I apologize in advance that these dots are not going to be perfectly spaced, anything like that. But this is 6 by 7. So 6 by 7 is one that you might not just know off the top of your head how many dots that is. And we're not going to sit here and count them, because that would make no sense, because as soon as we got to bigger numbers that we don't know, we would just waste all sorts of time doing that. What we're going to do to get to 6 by 7 is we're going to do 5 by 7, which is a lot easier because most of us can count by 5s. So we're going to count by 5s to get 5 by 7. All right, 5, 10, 15, 20, 25, 30, 35. All right, 7, that was counting 5 7 times, and that's going to give us 35. Awesome. So 35. So now how do we get to 6 times 7? Well, this is 5 sevens, right? So this is 6 sevens. So if we're adding another 7 essentially, then what are we doing? We're like I said, we're adding 7. So 35, that's going to give us 42, right? That is pretty awful for, but you get the idea. So we're just adding 7 to that 35 to get there. If we wanted to go 6 by 8, well, we know that 6 sevens is 42, so 6 times 8. So we've got 7 sixes right here. What if we want 8 sixes? Well, we're going to add 6 to that, right? So what we've done here is we started off. This was 6 by 7 right here. This grid is 6 by 7. There's 42 dots there. And we want to go to 6 by 8. So 1, 2, 3, 4, 5, 6. There's 6 in each of these rows, and we've got in each of these columns, sorry, and there is 7 columns. Well, what we want to do is we want to add an 8th column, so it gives 6 by 8, right? Then we just have to ask ourselves, how many dots are in that column? Well, we know that there's 6 rows, so there's going to be 6 dots, and so we're going to add 6 to this, which is going to give us 48. So that is what we're doing, is we're just anchoring ourselves at a point that we can come up with easily, and then we're moving to a harder one from there. So yep, that's usually what you do. I want to get into the nines trick real quick, and the nines trick comes from there's a few different ways to sort of get at nines, but 6. What do I want to do here? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. That's right. Okay. 8. All right, so this is 10 by 6. This is 60 dots, right? Well, if like I said with our last anchoring thing, if 6 by 10 is 60, then 6 by 9 is what? We've just got one less 6 there. So that is 60 minus 6, which is equal to 54. Because what we're doing is we're getting rid of, I'll just draw a circle around it. We're getting rid of this column right here, right? So then there's only 9 across instead of 10. How many dots are we getting rid of there? We're getting rid of 6 dots. And so that's going to get us that 54. And that's how you can always think about this. That's like usually, a lot of times that's how I do nines, is if you want 8 times 9, 8 times 9, there we go. So this is, hold on, here we go. Let me erase that so you can actually read it. This is 8 times 10. I'm going to put this in parentheses. Hopefully you guys know what that means. We're doing this first. And then we are subtracting off one of those 8s. So this is 80 minus 8 equals 72. The trick to, I guess the trick to like just come up with multiplication by 9 easily, now I'm just going to erase this real quick so I got room. The trick to doing that is the fact that you have, let's see, 9, 18, 27, 36. If you notice a pattern here, 45, 54, each of these things adds up to 9, and you're actually moving one up in the tens place every time, and each of these adds up to 9. So 5 plus 4 is 9, 4 plus 5 is 9, 3 plus 6 is 9, 2 plus 7 is 9, 1 plus 8 is 9. So these things always add up to 9. So a lot of times what I actually do is just, if I want 9 times whatever number up to 10, I guess. So 9 times 9, what I'm going to do, sorry, that'll get confusing if I do that. Let's do 9 times 8. 9 times 8, so all right, I've got 8 nines. I'm going to drop one off of this 8 for the tens place, so I'm going to make that a 7 for the tens place, and then I'm just, the second number makes this add up to 9. So what's that going to be? Bam, 72. Because what plus 7 equals 9? 2. So that's it, is we're just taking that 8, and what this also, the other way to think about this, like we said earlier, is you've got If you had 8 times 10, that would be 80, and now you've got 9 times 8, which is 8 less than 8 times 10, right? So there you go. 80 minus 8 is 72. Those are the couple tricks for 9s. Hopefully that will help you out. In my next video, we're going to get into some fractions, I think, and I know that's a really difficult one for people, so hopefully this helps out with some of the multiplication, some things that you can do with your kids at home. We will get into fractions next time. I am I will be back with some of that in just a little bit. Keep an eye out for it, and yeah, hopefully you'll learn something today. Thank you.